Good morning. Today we're going to be talking about the parts and pieces that we use in rigging. And I know we haven't got to play with rigging a lot this semester because of obvious reasons, but when we refer to rigging, that's anything that we're putting basically above people's heads. So when you were playing with the line set system a few weeks back and pulling ropes to make the battens go in and out, everything about that is a counterweight rigging system, right? That's the full name of it. So most of these are going to be used in the creation or use of that system. There are some other odds and ends that'll extend that a little bit more. But let's talk about each piece and how they're used to try to give you a little bit more of a visual representation, and we'll see some stuff in some other videos later today. So the first thing I want to talk about in rigging is we normally hang something in the air, right? That is the end goal, and all of these things help us to do that. But the first thing we need to think about, if it's not hung on something that is already installed, is it plumb, right? And by plumb, it's similar to using the level that we have in class, right? We want to make sure that bubble stays in the middle. If all of a sudden you have something that's going into the ground or something that's weird, it could be hanging out of plumb. If it's free hanging, like, oh, I don't have a string. Like if you took a quarter on a string and hung it there, that would most likely be plumb because gravity's for you, right? It helps you out. Now, if I take one of those battens and where the connections were at the bottom and move it all the way over like 5 or 6 feet, that cable is going to look like this, which is going to look weird and it's going to be out of plumb, which is not correct. It's not how they're installed. So the first thing we're going to talk about today is something called the plumb bob. Okay? And you see, this is an actual one. You see a lot of them. That might be any piece of metal tied to a string works as well, but this is a real one. And what this would be used for is using gravity as our friend to make sure things line up from the top to the bottom, right? If you're only doing one, it's hard to get it out of plumb. But if I make this connection solid and then we move to the next one, it might do this because I don't know how to math, okay? It happens. So the first thing we need to think about is the object plumb, okay? Plumb, meaning is it straight? Okay, so to dig into some of the other parts, one of the primary things we use, depending on what we're hanging, is called galvanized aircraft cable. You should write that down. Galvanized aircraft cable, otherwise known as GAC, G-A-C, okay? And a lot of the stuff we use, I should point out that everything that's on this table that I'm going to hold up for you, there are different sizes. Okay, you have tiny ones all the way up to massive ones used on cranes, because yes, a lot of this stuff is used to that scale as well. So this is a small gauge GAC. Clark, can you see that? Small gauge GAC, galvanized aircraft cable, and this is 1/8 inch diameter. Okay, it can go down to 1/16, and I think the biggest I've seen is like 1.5 inches, but there is bigger. And it gets its name because it was originally used on aircraft. This stuff pulls planes. It's strong. Maybe not this diameter, but that's what it's primarily used for, okay? And it's used in great relief with us here, but what you need to look at is it's essentially wrapped cable, okay? I'll send you a picture in a supplementary material that if I were to cut this open and you were looking at it really close, you'd be able to see that it's actually woven strands of wire, getting much, 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 much more strong. If I were to take one piece of hair, bink, I could snap it, right? But if it was a whole braid of hair, it gets a lot stronger, okay? And that's the same principle this works on, except it's steel. So it gets a lot stronger. And they all come in different weaves, you could say. This one is 7 by 19, okay? Most of the ones that we use are 7 by 19. That will be a test question. So, 7 by 19. Galvanized aircraft cable. Here's an example of one that's a little thicker, right? Obviously, this one's going to be stronger. We can talk about exact like weight ratios and stuff if you'd like. That's for me to nerd out about. But for most of the stuff we do, you can basically say this one covers most things. This all the way up to 1/4 inch is what we normally use for lifting scenery in theater. If we're doing something this big, it's probably a massive show, Broadway level, or we're hanging huge amounts of weight, okay? For what we do in our theater, it's not all that necessary. So I have a pipe and I have aircraft cable. How can those two connect to be able to actually make a thing work, right? We have lots of options. The first one is something everybody has probably seen, I hope. We'll talk about that one later, Clark. This is basic chain, and we can wrap a pipe, if my arm is a pipe or a batten, to be able to make that work, right? That is a strong connection up top, and then we have a little V here, okay? And we'll go back into this in a second. We have an item called a shackle that then we could hook into this, and then it can move down the line. Why do we care about different size chains? Okay? They're all thick, they all have different weight ratios, just like everything else. Safe working load. We always want to make sure that this is not the weakest part of our system. And when we talk about rigging, that is the primary thing to think about, right? Everything that we do here is based on what is the weakest link. Pretty common terminology. If there's a weak link in anything in here, it becomes an issue, and that's when we have accidents. So, you just have to basically engineer whatever system you're working with. We over-engineer everything to make sure that you're not pushing any one object. If you want to, I'm going to come in close to you real quick, Clark. Coming out of frame, I know. Yell at me later. So I picked up this chain, and somebody's actually wired it together. So this chain is rated for a good amount of weight. Now what's it rated for? Absolutely nothing. This is trash. But it's a great example as to what we're looking for, right? Obviously, this is very clearly trash, but if we're connecting a few of these objects together and one of them is rated for 10 pounds and not 400, that's where it's going to break. So whatever system you end up engineering, you need to make sure that it can handle the weight, okay? And that was a long, drawn-out explanation. When we haven't gone through the pieces, I apologize. We'll get to it. So, parts and pieces. So when we connect that wonderful wrapped cable we just talked about to the bottom of the chain, at the very bottom, we're probably going to put a shackle, which this might be small, but you'll be able to see this one. Okay? So this is called a shackle. Okay? It has a very simple concept. There's a few different variants, which we'll talk about a little bit later, but this one's a pin shackle. Okay? Which means basically you can unscrew it, put whatever you need to in here, and close it. Now, if you're working with some people who've been doing it for a while, there are preferences in using these, but I will tell you that there is it's just a preference. You can use these bell up or bell down. Both of them are the same strength, and both of them are acceptable. The whole idea is that your plumb and your weight is down here, and your lifting hook is up here, right? Whatever that may be. The only way you can use these incorrectly is if you end up in a situation where you've hung weight like this, okay? These are not designed for that. They're called side loading, okay? That is incorrect 100%. Normally when we start looking at these, this one actually has it, you won't be able to see it on camera, there's actually a mark that shows how far you're allowed to hang it, because often you'll have 2 points coming off of it called a bridle. It goes a little further, but you're allowed to hang within that degree. If you go past it, you're pushing side load, and we don't do that. Side loading is bad, okay? So that is your basic shackle. Once again, they come in a lot of different sizes. And you could probably, much smaller than this and much bigger than this. These are often used in cranes, okay? So that goes for the shackle, that runs down, and then we have the actual lifting eye, okay? If we look at this, it comes in a few different parts and pieces, okay? You have your galvanized aircraft cable. You have a thimble, right? For those of you who have sewn or played Monopoly, thimble normally goes in your finger. Same concept here, right? It goes in here and it wraps around, the cable wraps around it. What this does is stops the cable from being kinked, okay? Just like a water hose, you don't want to stop that flow, okay? It makes things a little weaker on the end point. And what brings it together is called a Nyko press. That is a brand name, I apologize. It's called a Nyko, but it's also called a swage or a sleeve, depending on who you're talking to and what you're doing. To give you a little bit better view on this, this is the size we normally use, all the way up to about this size. And they get much, much bigger, okay? And how these work, is you end up taking your cable, running it through all these little tiny metal things. I cut it because they start to fray and you can't get it through. And since I'm not really worried about the link on this because it's a demo, we don't have much of a problem. But what you end up doing is putting that through one side of it, setting up your sleeve or your thimble, working it around and dropping it back in, right? So you get this wonderful little lasso-y effect. And when you put these together and pull this tighter, boop, you end up with a lifting point. Now, as you could probably tell, we've just worked that around and there's nothing holding this at all, okay? I could still pull this apart if I wanted to. There's no weight on it. So how do we get it to the point where this swage can hold these two together? Cool. We have a few different tools for that. We have an actual Nyko press. Once again, we can call it a press, swage press. There's lots of names for it. The biggest trick is to realize what cable diameter you have, and they're all labeled for your convenience. This one's getting a little loose, we need to tighten it up. So, what we end up doing here is figuring out which one it goes under. This one's actually marked by number. And we want to make sure that we put the press in here sideways. If we do it this way, it will not work. So what we're looking for is this way. And once we realize that we're using 1/8 inch cable, it's all lined up. And depending on the current methodologies, there's an order that you need to press these, and we should look that up. That was actually the wrong one, rookie. But I just want to show you what it's going to do when you press it. So you get these wonderful little swage lines. And this diameter cable requires 3 different swages. Okay? And as we work it through, it starts to be pressed and clean. You end up with 3 nice ones. Mine weren't so nice that time. You can see the 3 different presses. And there's a bubble in the middle of this one, but that's completely okay. Okay, because they got all 3 in, and they didn't put too much pressure on this. So what this does is that swage that we're talking about, they normally, the ones we use come in 2 different types of metal. One is aluminum and one is copper. And the biggest things about these to think about is copper's a little more malleable and we'll get in there. It's more for a permanent installation. And it's a little more forgiving about getting beat around. Aluminum, on the other hand, ends up getting small microfractures, which over time could break. So if you're doing a permanent installation, we want to use copper. At least that's how I've always been taught. Aluminum's just fine for what we're doing. Quite often you'll find these little Nykos that look like they're aluminum, but they're actually copper. Any idea why? There's 2 different reasons. One, some different metals will react different to the copper. And the one that I've heard most commonly in the industry, people like to steal copper. They don't steal aluminum. It's not worth as much. But those are the primary reasons. Once we smash these together in this orientation, where you end up with 3 beautiful presses on this size, it actually works the metal in between the small little ribbing that happens in the cable. And it doesn't let it pull through anymore. Okay, it's really kind of ingenious how it works, and you can take a cross section. If I was to go cut this in half, I could show you actually where the metal has worked inside the cable, creating essentially a 100% strength retention in this. I forget the percentile, but it's high 90s, like it's really good. So that's how that works, and that's how that swaging works. Okay. And once again, the first time you have to do this, we'll talk through it again. Or whoever you're working with should talk through it again. But those are big things to know, okay? If you can swage a cable, that's 90% of the battle. Now, we have a few other parts and pieces we need to talk about. One, you saw me pick up this little tool before. The only thing this should ever cut is cable. If you cut anything other than cable with it, it will dull them. And they're really expensive and fun, and they do their job nicely. So this finished wonderful swage that I messed up on, that's why you should always check your tool. Cable cuts, right? One of the things that we need to consider when cutting these is you will get little splays of metal, okay? Which means you should have safety glasses just in case something stupid happens, okay? But it does cut it very cleanly and safely. Cool. Now, you have the option of its bigger brother, okay? Can these cut that? Yes, no problem. It's probably not necessary to lug these around though, if those will work. This is also, those are called C7s, by the way. I forgot the name after talking with it. These are called C7s. And these are your big boy aircraft cable cutters, okay? I forget the name. Clark, go ahead.
C12.
These are specifically a C12. Thank you. And these can cut much thicker cable, okay? The only thing that these get used wrong on is if you're cutting rope. I see people cut rope with them all the time. It's like taking a knife and cutting cardboard. It's gonna dull it, okay? Which, I digress, we need to go back to one other thing. When we were talking about the swaging earlier, if you swage one of these, there's little gauges that come with these tools, okay? That lock in, which I don't think we brought out. But they lock in to show that this tool is actually calibrated properly to crimp the cable, okay? So it varies depending on who you talk to. Some people will say check every one. If I can check one every 25 or 30 if we're doing a lot of them to make sure that they're still good, we're normally good to go, right? What'll happen with these is if they're not crimping all the way, you won't be able to get the gauge over the top, which either means you're using the wrong hole or the tool just needs to be adjusted, okay? It's always something just to check before you start because you don't want to end up hanging 100 points in the air and have to go back. We don't like that. Okay, so we've gone through the thimble that goes around the cable. We've gone through the NICO. We've talked about gack and chain. Let's go back and talk about a few of the other little things that we can use. This right here is called a span set, okay? Which we'll have a supplementary video for that as well. But span sets are used for a lot of different things. They can carry a lot of weight, right? We normally use them up high in a few different configurations. We have our vertical hang, our basket hang, where you'd actually connect the two. And then you have your choke, right? Where you actually just take it around something, and that works as well. And we'll have a little video showing you how to do that in just a minute. It is important to talk about a few other little things with this. One, just like all the other tools and everything else we've talked about, before you use it, you should inspect it, right? If there's cuts or tears in the outside jacket, don't use it. It's that easy. Inside here is a whole bunch of little synthetic fibers, used very similar as the gack. There's a lot of them, and that's what gives it its strength. All of them will have a tag that will tell you all three orientations to be able to tell you how much this one's rated to lift. To give you a rough idea, in basket formation, this one holds over 10,000 pounds. A lot of weight can be held on these, okay? In the last couple years, we've seen a new advent of span set come through. Span set's also a brand name. And they're called gack flexes, which instead of that fiber that's inside of here, it's actually a whole bunch of strings of this. Any idea why people started doing this? It's pretty easy. They're worried about fire, okay? In the instance of a fire, say I'm hanging a motor up in the air, which doesn't help because we don't have one of those to show you, but a motor up in the air for a Broadway show to do a thing. And you're gonna leave it in there for a couple weeks. It's probably not a big deal for a couple weeks. But if it's a permanent installation, all of a sudden, fire becomes an issue. What happens if fire goes all, because these are normally really up high. What happens if fire occurs? It will melt over time, right? And then whatever it's holding will then fall. We've compromised the integrity of this. If it's gack flex, chances are it's not going anywhere. It's a piece of metal in there. So it's gonna be fine. And that was the big switch in the industry for that, okay? So, a few other little parts that we can talk about. Sometimes, we don't wanna necessarily use a NICO because they're more permanent. sometimes it's better to use one of these little guys. Cool. These are called, their brand names are called Crosby's, okay? Crosby makes a lot of these products though, so we want to call them cable clips, okay? And if we look really close, I don't know if you can see it on camera, this one's a 1/4 inch, so it's meant for 1/4 inch cable. You want to make sure when you're using this, as you can tell, these are the wonderful parts and pieces. You want to make sure that when we're using this, we're using it the right way. And this is obviously a small cable. Don't laugh at me. We'd normally use 2 of them, or 3, depending on their application. And we want to make sure that the cable sits in there. And then you end up doing the same thing you do here with the wrapping. Put it in here and then tighten it down to manufacturer standards. These do all come with a torque setting that you could get a torque wrench and make sure you're perfect. As long as they're tight but not over tight, you're normally okay, but there is a specified torque setting, okay? Biggest thing I see done with these wrong, okay? This is called the saddle, okay? And if you end up doing it backwards, it isn't rated correctly. And by backwards, I mean your dead end of the cable, I need another cable, that ends up wrapping around. So if this was this is your dead end. 1 second, be right back.